I started working early stages with the automotive industry, and with self-driving cars, what we see is that you have a fleet of cars driving around the city, driving around different locations outside the city, and most of the footage isn't really useful to train a new model. There is not much is new is happening. But when there is a special case, so maybe it's a special scene, maybe it's a special event, maybe someone is overtaking you, maybe some special car or a certain road sign that you want not to just put it in the lab, and then obviously you can record as many of examples of that road sign in the lab, but in real life with the real scene, a real environment, then you have a handful of those. So you have a handful of examples that are actually useful. Bridges, tunnels, things that you don't necessarily have a lot of examples of. But then again, you have driven through the entire day, and you have multiple cameras, multiple vehicles, and you need to find those specific examples. So that is a very, for us, because we work with autonomous vehicles and the vehicle industry in general, that's a use case that we pride on, that we help them sift through huge data sets.
Good morning, good afternoon, everyone, to the AI and Digital Transformation Podcast. In this podcast, you'll get to learn more about the different AI use cases that you can implement in your own small and medium businesses. So for today, our guest is Alexander Berkovich. He's based right now in Australia, and he's currently the principal AI and machine learning engineer for Akridata, an AI copilot, computer vision AI copilot. So welcome, Alexander.
Welcome.
Thank you. Great to be here.
So before we begin, maybe you could tell us more about yourself, like your story and how you ended up doing these sorts of computer vision AI copilots for Akridata.
Absolutely. So my entire career has been around computer vision. I've always been drawn to technical aspects of development, R&D. I was working in different areas, in different spheres, developing different systems or algorithms for my entire career, again, straight after uni. And at the moment, what we do with Akridata is we work with visual data, any type of visual data. So it could be X-ray, IR, it could be obviously cameras, any type of video. The idea is to make life easier for everyone who works with that type of data. Any type of visual data could be used for automation, for different systems. Maybe we'll talk about it in a few minutes. And I've been always drawn to these types of systems because we as people, we always have so much input coming through our eyes. We take the environment through our eyes, obviously through other sensors, but a lot of information is visible, and systems, machines can potentially utilize that information as well, draw conclusions, make decisions, and we see it already, obviously, around us, not new. So that's always fascinating. And now we work with our clients to do the same.
But I think we could start by getting a bit deeper into what computer vision copilot is. I mean, our listeners by now should know very well what a text copilot is, or like the ones used in a GitHub for programmers, or the one developed by Microsoft for their Office suite. But what is exactly a computer vision copilot, and how can speed up the tasks of your clients?
Absolutely. So modern computer vision is all about volumes, quality, but also volume. Data for any application based on vision obviously needs to be acquired typically you have a huge amount of data. So how do you curate it? How do you clean it? How do you use only the relevant parts of thousands, potentially tens of thousands of images or hours of video? We offer tools to do that interactively, to do it significantly quicker than you would have done it without our tools. That's step one. Again, modern computer vision relies on what we refer to as deep learning models for the most part of it. And that relies some sort of labeling, ground truth. That is also something that we offer. So labeling is typically manual. It's typically a very time-consuming, resource-consuming. You have to have high-quality labels. You want to have the best data possible to train a model on, to test the model on. And we help you curate that data. Sometimes you don't have enough examples. So when you work with defect detection, when you work with something that's very rare, that is the actual thing that you want to detect, but you don't have enough examples. Recent development allows you to generate synthetic data that looks very, very similar to the real thing. And that is also something that we can offer. So we've started with acquisition. Now we can select the best images, the best frames, select the most relevant images. We can label it. We can add, enrich your data with synthetic information. And now you're ready to train the model. Once you've trained the model, how are you going to test it? Again, we offer a way to do it interactively, to do it really intuitively, no code involved by the user. So starting from the acquisition step up until the point that you already have a model, we help save time, self-development cost, obviously make it a lot more user-friendly. So you don't need to be an expert in a certain field to be able to train a model to deploy a system.
And I'm just trying to picture. So I guess you have clients from different sizes, right? Like from small sizes to, I guess, large corporations. So I was thinking, how much, could you give us a breakdown of the timeline for these processes? For example, maybe you need more time to make sure that the data is good, that it's clean, that it's annotated, that it's labeled, and then you also need time to build the model, to make sure the model works, and then to deploy it. Do you think you can tell us an estimate of how much, not energy, how much effort you use for these different stages?
For sure. So first of all, I think it really depends on your use case. Different use cases might involve different volumes of data. So you can start with, again, it doesn't have to be a small company. It can be a large company with a very specific niche use case, or a small company with a huge amount of data. And it can vary maybe between a few hundreds of examples. Obviously, you can go a few lower. And you can reach up to millions of images, hours upon hours upon hours of video footage. Based on the volume of data, you can obviously imagine it might take between a few hours to maybe a few weeks to curate a good data set. And you start with that step, because I always say that data is your gold. If you have high quality data, then you can rely on it. You can build a good application based on it. If you don't have high quality data, no matter how good your model is, the system won't work in production, right? If you trained it on something that's inaccurate, something that's misleading, then obviously in production it will fail. So you've spent hours, days, weeks preparing your data set. Now what about the model? Models are available in different frameworks, and you can develop your own models. You can take readily available models that are open source, and you can retrain them. You can use them as is. Maybe you can fine tune them. Obviously, you can create your own model, and that varies greatly based on the task. It could take maybe a couple of hours to take a model that's off the shelf retrain it on a small data set. Really, it could take you a few hours if you have the infrastructure ready, if you have a good GPU, maybe you're working on the cloud and you have a good instance on AWS or other available resources. 2 hours, 3 hours, you're ready to deploy a first version. And on the other hand, you have spent a few weeks, you have curated a huge data set, and you have a very complicated pipeline. Each step of the pipeline is a very complicated model, and you need to retrain that model maybe from scratch, maybe from a previous version. That in itself could take a few good days, if not more, multiplied by a few models, and you have reached already a month's worth of work. Obviously, testing, rigorous testing, depends on what accuracy you need. And it's not necessarily for small companies you would go with a small model, or a big company with something more complicated. It's more about the use case. So accuracy could vary. Some would say 95% accuracy is awesome for them. Maybe they're using something that's relatively trivial, 5% there, no worries. Someone else is saying 99.99 is the bare minimum. Maybe safety, maybe the implication of 1 in a million accidents is catastrophic.
So can you give us a few examples of how exactly your copilot helps curating the data set? What are the functionality that the copilot provides exactly?
Absolutely. So as mentioned, one of the first steps you might want to do is to curate your data. Let's say you have acquired a few thousands of images, and this is raw. You have no idea what you have acquired. So first thing, we offer a visualization of the data set. Based on raw content, you can visualize the data. You can split it into different subclasses automatically. You can split it into subgroups, and you can focus on each group separately. Why is that good? Let's say, again, you have acquired a few thousands of frames by driving around, or maybe you have a video of a certain field in the agriculture category. Most of it is redundant. You don't really need any, the vast majority of it. You just need to select things. So you can focus on what's relevant. You can focus based on maybe it's a different types of scenes. Once you did that, Data Explorer, our copilot, allows you to search the data set. And this search could be based on visual search. So you've marked a certain item and you want to find more of that. As an example, you're working in a plant and you want to find people wearing helmets. Okay, so your data set will include lots of people with helmets versus people without helmets. Okay, so obviously, again, a lot of frames might be redundant, but what we allow is for you to mark a person with a helmet and search for the data set. Within a few seconds, you will find more examples of people with helmets. Similarly, you're going to mark people without helmets. You're going to find people without helmets within the data set. So out of maybe 10, 20,000, you're left with 5,000 that are very relevant for you. Step 1. Step 2, annotation. We're going to annotate that data set that you have curated. And in some cases, we're also going to look at synthetic data for you. Maybe there is a rare case of a certain defect that we can generate more examples of and enrich your data set. So we can search through the data. We support different methods of searches, visual search, text-based search, prompt-based, text-based search. You can do some sort of filtering. Maybe you can sample the data set. Again, to select the relevant images. You can, as mentioned, label that synthetic data to enrich it. And finally, once you already have a model, there are common metrics to evaluate a model's accuracy. What we offer is the interactivity to connect those metrics to the data itself.
I can already hear the question of some of our listeners. And they would ask, well, but if there's already a model that can look for what I need to, can find what I need to in the data set and can help me annotate it, isn't that already a good model? Why do I need to train another model?
That's indeed one of the common questions that were asked. We help you build that data set. So our performance will be very interactive. The system works in real time. The system works really well to build your data set. So if you have 0, you will, within minutes, you will have the first 100, maybe the first 1,000 images. But it won't be as accurate as a very, very custom model trained on your data. So maybe you'll get from 0 to 60% within a couple of hours based on what we offer. From the 60% to the 85 to the 95 to the 99, that's what you are going to do based on what we offer.
I have a question about that, like for the both of you, since I'm not an AI engineer. Is accuracy very important for computer vision projects? Because, like, for example, generative AI text-based generated content, the people don't really care if it's that accurate. Well, I think in computer vision, I'm guessing, or from this conversation, I'm feeling that it's really important to have a high accuracy.
It really depends on the application. It's like, and also, this might be a bit technical, but first of all, accuracy is a very generic metric that it's easy to explain to someone who doesn't do machine learning. But usually, when you have a classification task, like you're more interested in 2 other metrics that are like precision and recall. And basically, it's like recall is how many samples, for example, how many people with helmets you find among all the people who are actually wearing an helmet, right?
Mm-hmm.
And while precision is how many of the people labeled as with helmets are actually wearing an helmet. And that's interesting because different applications care more about precision and other care more about recall. It's like, for example, in medicine, usually you care when it's about early detection of cancer or for other diseases, you care more about recall because usually, like, you don't want to miss any potential cancer, right? But you are willing to spend extra money in testing someone who doesn't have cancer, just because it might have. While in other application, let's say, for example, biometric, if you use it for access control to a building using face recognition, you care more about precision. Like, if you say someone can enter, you must be pretty sure that's the right person. So,
okay.
I don't know if did they make sense to you?
Yeah.
Like, I don't know if I think your clients already dabble with this kind of metrics. They're all data scientists, I guess, right? Or they are people who don't know much about data science and they just come because they need a quick model without knowing data science.
So we usually work with more, let's call it professional teams. Whether or not it's small or large corporation, typically the user will have some experience with data science, some understanding of what they need, and as you mentioned, some understanding of what's more important, whether or not it's the accuracy or, for example, speed. Maybe it's also an aspect, the performance, how fast a certain model can run. That's also sometimes a concern. And an example that you have brought, it's a great example with cancer. And different detection systems. So, for example, you're working on corrosion detection, you're working on inspection of a certain structure, a bridge or a house or a building, and you're trying to see if there are any defects or cracks, and maybe you want to monitor a certain crack. Some cracks might not be a threat to the structure at the moment, but if they evolve, if they become too big, then they could be a threat. So you want to detect them early on. Maybe you don't care if you over-detect to some extent. And sometimes you don't really care. You missed. Okay, so you missed. No bad.
Yeah, it is very application dependent.
Yeah.
There's no golden rule, good for everything. That's why I think that's a good and the bad of this age of machine learning, where making a model is relatively easy, I might say, and there are some tools that make it easier, like the ones you work on. But in general, it's much easier than before. Like the other side usually of, and probably something that's powering your system as well. So that one of the technology that make models development much faster is an aspect called transfer learning, where basically you use a model that is trained for a general purpose, and then you reuse it, you fine tune it on your specific application. Mm-hmm. So and this like helps me asking you the next question, which is like sometimes with transfer learning, you don't need that many samples to achieve decent accuracy. So what would you say is are the typical context use cases where you see that your customers still need a big data set in order to achieve the results?
I think specifically for, we work with different manufacturers, and obviously each manufacturer have their own use case. So for example, we're working with a railroad company, and they test, they evaluate and inspect the wheels of different trains, different cargo devices, without a better word. And these are very, very specific. This is a very specific domain. You wouldn't find it in a publicly available data set. You typically don't have those. You typically have something that's the common objects, like the cars, the people, the flowers, and a very specific defect might look extremely unique. So people who have a very niche type of application, they would need a lot of examples of those specific defects. And obviously in these cases, the implication of missing a defect could be extremely bad. As mentioned, obviously, train having a crash or even stopping in the middle of nowhere has a huge implication. So if you are working on something that's very common, vehicle detection, people detection, faces, then maybe you're good with transfer learning or very small data set, because you already have a good base model to start with. If you have a niche use case, then you might need tens of thousands, hundreds of thousands more examples. So
yeah, especially if you need a very high precision or recall or accuracy in general.
Yeah,
because that's always the, let's say, the big factor, right? Because usually the more high you want the accuracy to be, the more specialized the model needs to be as well. And so the more data you also need in order to train a specialized model. And I think maybe another context where your technology is very useful is, again, when maybe you need a few samples, but you need to extract those samples from a very large corpus of images.
Yes. So we started, Akridata started working early stages with the automotive industry, and with self-driving cars, what we see is that you have a fleet of cars driving around the city, driving around in different locations outside the city, and most of the footage isn't really useful to train a new model. There is not much is new is happening. But when there is a special case, so maybe it's a special scene, maybe it's a special event, maybe someone is overtaking you, maybe some special car or a certain road sign that you want not to just put it in the lab, and then obviously you can record as many of examples of that road sign in the lab, but in real life with the real scene, a real environment, then you have a handful of those. So you have a handful of examples that are actually useful. Bridges, tunnels, things that you don't necessarily have a lot of examples of. But then again, you have driven through the entire day and you have multiple cameras, multiple vehicles, and you need to find those specific examples. So that is a very, for us, because we work with autonomous vehicles and vehicle industry in general, that's a use case that we pride on, that we help them sift through huge data sets to find very specific examples to train models. Again, it could be road signs, it could be bridges, other events.
Yeah, in a way, I think it's fascinating because it's a iterative way of building the model. Like you start with just a very few examples and you tell the systems, look, this is what I'm looking for. And so the system doesn't really know very well what you're looking for, but uses this gross description to do a first filtering. And maybe it returns you, 100 images and only 20 are useful. But then you get these 20, you give them to the system, and the system gets better at understanding what you need. So the next round, it will give you other 100 images maybe, but this time 50 of them are relevant, and so on. And it goes on. It's like you build, like the better your model gets, the better it helps you collecting even more data, and so you can get an even better model.
So it's like a video game, like you try, I don't know, I don't think Tamagotchi is a right analogy. Like
No.
you try to feed the Tamagotchi and you take care of the Tamagotchi and it learns some new stuff. I don't know. Maybe it's the wrong analogy, but like in a video game, you train this object or this animal to do something over time, more and more data until it gets better. Like you do iteration cycles of like repeated learning, let's say, right?
Yeah. In a way, it's like tutoring, right? You teach a student, and then that student helps you tutor more students. And it's a cycle that repeats in itself.
Yeah.
So it's kind of cool. You can also do it manually if you're a good data scientist, but for sure having a tool makes it easier and faster. So it's it's good to use it, especially if you are very visual and you want to have a fast, really start up it quickly. So those tools are very useful, and I'm happy we had a chance of discussing one of them with Alexander today.
So Alexander, do you think, as you said, you worked already with professionals, so like data science teams, what if, for example, there's this company maybe, and they don't really have a data science team. They said they have some data, but they really don't have that much education or familiarity of how good a data should be or how to even collect good data. Is your company willing to guide them, or do you strongly suggest that they should first have a strong data science team and then get back to you?
So first of all, we're more than happy to work with anyone with a challenge within the computer vision space. And that's something that we take very seriously. We offer not only the tools for anyone who wants to use them, but we offer the solutions. We offer help in building systems. And my first golden rule is that if an expert can see something and they can draw conclusions, a machine at some point will be able to do the same. if you can reliably look at an image and draw a certain conclusion, again, make a certain decision, then we should be able to help a machine do the same thing. And if you have data and you're an expert in your field, you're not necessarily a person who worked in computer vision, you're not a data scientist, but you already have a visual data and you know what you want to extract from that data, we are definitely working with you to help you extract the relevant information. Data Explorer is built specifically for that use case where you don't need to code, you don't need to have a lot of understanding of computer vision. You do need to have your data, and you need to know what you want from your data. Maybe you want to clean it, maybe you want to extract some things, and we are more than happy to work with you to extract the most relevant information from your data, and of course to build a system based on your data. So that's definitely part of our services.
Then I have another question, because like it could be surveillance, which is a hot topic for, data privacy and everything, or it could be like manufacturing maintenance. So you look at data in terms of objects. There's this documentary I watched some time ago where this researcher, I think from MIT or somewhere, was trying to show the bias that's happening in computer vision. So they were not able to detect African American people in cameras, and so it sparked the conversation in the internet on how the tendency for biased data to pop up in computer vision projects. Do you have a way to make to evaluate this kind of issue?
Absolutely. So when we spoke previously about let's assume that we have a data set and we have a certain use case for the data set. So you've mentioned that we want to detect people. Obviously, we want to detect all types of people. One question is, does your data set, your examples, contain examples of all types of people? And what we see is that a lot of open source datasets, they don't. They contain a very small subset of people from a certain, maybe university, maybe a certain city, not diverse at all. Not diverse, no edge cases, not very homogeneous. And a model that will be trained on that dataset will obviously be very, very performing very poorly on a different group of people. So when you deploy it to production, you want to when you deploy a model to production, when you deploy a system, you need to know what's the current use case that you'll have. Again, we're talking about people, so obviously you need to detect all people. So your data should detect all people. We've talked about transfer learning, and that is a potential risk when you take something that you don't necessarily know what data set a model was trained on. So it could be some sort of internal bias that you're not aware of. How do we address that problem? First of all, we're looking at your data set, and we can see how balanced it is between the different classes. So maybe we're talking about people from different backgrounds, and we'll be able to determine that you don't have enough examples from this type of background or from another type of background. Obviously, if it's a certain different classes, so between the different classes, what Data Explorer can semi-automatically, in some cases fully automatically, determine how many examples you have from each class. If your data set is not balanced, if it's very, very skewed to a certain group, then the performance will be very, very poor on the other. Right? If you weren't trained on detecting a certain object, you won't be able to generalize. And Data Explorer does allow you to understand your data, understand whether or not the data is biased. If the data is biased, most likely your model will be biased. There is no way around it.
Yeah. I will only add that I think most models have been trained on biased data sets. It's just that computer vision bias is more obvious because you can look at the picture and you can tell, yeah, well, look, there are no African Americans in this data set, and wait, it's supposed to work in America, so that's a problem, right? And it's just more obvious compared to other types of data, but it's a common problem in all that spans across all applications of AI and machine learning.
Which is why I just want to emphasize, when you build an application, you want to know what it should do. When you know what it should do, you need to build your data set accordingly. If you want to work with people, you need to have all types of backgrounds in your data set. And there was another example where we saw a bias detecting between doctors and nurses. So instead of looking at, you would distinguish between a doctor and a nurse by their by their clothing, right? And what we saw is that a certain model was classifying based on gender, which meant that the data set was extremely biased.
Yeah,
which is very unfortunate, and it obviously means that the performance will be extremely low, right? So that is an important thing to discover as early on as possible. Something that maybe could help, and that's also something that's available through Data Explorer, is a saliency map, a heat map. So typically a computer vision model is, any deep learning model is treated as a black box. So you get an output. If it's great, everything's great, everyone's happy. But if it's not accurate, we don't necessarily know why that's not accurate. Generating saliency map, generating heat maps is a way to understand which part of an image affected the model's output. So if a model is focusing on the background, if it's not looking at your object, you know that there's something wrong. If the model is focusing on the wrong part of the object, you also know that the model isn't learning what you expect it to learn.
Yeah.
There was an example from a few years back where a model was a certain system was trained in a way that it distinguished between sick and healthy people, not based on I think it was an X-ray or some other medical image, but not based on the organ, but based on a certain tag that the image had, which then obviously told the model this tag belongs to a sick person and this tag belongs to a healthy person.
Yeah. So we can say that these models are very, very good at cheating.
Why? Why?
They're very good at cheating because they're lazy and they're good at cheating. So, so if there's an easier way, like think of it, like in the case of doctors and nurses, right? If you see that 99% of the doctors are males and 99% of the nurses are female, the lazy cheating part is saying, okay, males are doctors, nurses are females. That's it. Or you find the tag. But to be honest, like that's also how we work as humans. Like
we assume
we work on bias because we couldn't consider all factors of the decision. So we are biased naturally.
Yeah.
The problem is not really if there's a bias, because every data set has a bias.
Yeah.
The issue really is that it is biased with comparison to what you want to achieve. Like, for example, the Afro-American case.
Okay.
If your goal is to, identify Chinese citizen in China, you don't care about the fact that you don't have Afro-American in your dataset, because that would be like enormous irrelevant use case, right? You don't care. You want to have a lot, but you want to have Chinese faces from all ethnical groups of China. Whereas if you care about identifying a person, you don't care about having equally distributed ethnic group of Chinese. You just, you don't care. So it's like, even the definition of bias is like, depends what you're doing. And so I would say, if I can add one last thing, that what Alexander said is like, we only need people to come in with data, of course, and with the knowledge of what they want to do with the data. And it's not a given, because knowing exactly what you want to do with the data, it sounds obvious, but it's not a given. Some people are like, oh, I have this data, but they have a very vague idea of what they want to do with it.
It's like in my case, communication, they say we have this post, but we don't have a strategy. It's like,
yeah.
No roadmap.
Do you agree, Alexander?
Sometimes having a vision is not as easy as someone might think. Yes. I just want maybe to add to the previous point. Many models are indeed biased, the data sets are indeed biased, and what we found was that our clients, they very differ in the sense that sometimes they work on a very niche examples, and yes, you have the bias and you need to solve it. And on the other hand, we have a lot of manufacturing use cases where this doesn't exist at all, because it's such a specific task that all these biases, they're just irrelevant.
Yeah.
There are no people, there are no biases that we as society introduce. You have a certain defect, you have another defect, and you need to solve for that, and you don't have any predetermined bias that you might think about or something like that. So very, very different atmosphere even.
Yeah, it's like what I said a while ago, like surveillance for sure that has a risk of bias, a larger risk of bias compared to, let's say, monitoring a cracks.
Yes.
You cannot be too creative with the cracks.
Yes, because in that case, you control the data generation process. So it's, you sample from the data generation process until you have a full data set. But the issue with that kind of data is that when the data generation process, let's say a new machine is added to the production line, then the performance of your model can drastically drop, because now you have out of distribution data because the data generation process changed. So but that's a flip side. But once again, probably some of the tools that Alexander's tool provides are detection system for out of distribution data. So my question was that in a very controlled data generation processes, like the data coming from a production line at a company, you can generate a full data set given enough time with no bias. The problem is when the data generation process changes, because maybe there's been a change in the production line. Let's say a new machine has been added with a somehow different technology. So my question was like, does your copilot solution also provide some tools to detect out of distribution data?
Absolutely. We have something that we haven't mentioned in the past, but it is a way to compare different data sets, and it's exactly for this use case. You might think, okay, I deployed the first version of the model, I've deployed the first version of the system, everything's done, no further work is needed. In reality, it's not the case. In reality, things are very dynamic, whether or not it's changes to the hardware, to the even illumination, to the process itself. Things change, maybe not on a daily basis, but every few months things change. And then you need to, exactly like you said, identify these changes. What we offer is a way to compare a different data set. So maybe you have a data set from the first quarter of the year, and then you have a data set from the second quarter of the year. And when the distributions are different, we show that. We show that straight away that they don't project to the same areas of a plane, and you know that you have a problem. Maybe it's not an immediate concern. Maybe it's something wanted. Maybe it's a good thing. Something changed in the process for the better. But you know that there is a change, and you can identify it. You can address it. Maybe you need to retrain. Maybe you need to do the whole process all over again of curating and labeling and retraining a model. Maybe no. Maybe you're happy. Maybe everything is good now with the new process and you don't need to do anything. That actually allows you to identify that really easily. And you can do that continuously. So you can do a comparison on maybe weekly, maybe monthly basis. And obviously you will see if things change, if you see drifts in the data. And that is something very subtle, but also very important.
Thank you, Alexander. I think today we discussed interesting tool that, together with other similar tools, can speed up the development of machine learning solutions. So I hope our listeners will find this interesting, as we did. Now, do you have anything else you'd want to add?
I think for now we've covered like a general overview of how computer vision AI copilot works in different use cases, like what they should account for, what they shouldn't. But yeah, for now, I think we've touched a lot of interesting topics. And before we let you go, Alexander, I'd like to ask you one final question. Do you have a book that you can recommend to our listeners? It doesn't have to be on AI, but it could be.
I think I like different what you can find on Coursera. I think Coursera offers different courses, different lectures, maybe different sources of information for different levels, and you can have it in different languages. You can have it for beginners and obviously experts. So I think that's a good place to start or learn something, or to start learning something.
Unconventional, Coursera.
Yeah, but really a book, but it's a good learning tool. Yeah, Coursera, Udemy are all the nice solutions.
Thank you, Alexander, for this wonderful conversation. And for our listeners, if you like this episode, please share this with your friends or colleagues.
Thanks again, Alexander, and till next time.
Bye.
Bye.
Thank you.